Can you see it now?
Yep.
Okay, so this proposal is regarding to leverage eBPF for traffic redirection in Ambient. So as we know, currently Ambient rely on the IP tables and GNU tunnel to redirect pod traffic to the Z-tunnel pod on the SIM node. So this approach is error-prone and low performance. So the eBPF is a natural choice to replace it. So this is some background information. For the requirement parts, actually, because in our eBPM program, we rely on the TC, the traffic control hook. So this this TC hook is existing in kernel for long time. So basically, it means this proposal doesn't require very newer kernel version. So in theory, the version greater than 4.20 should work. But in our prototype verification work, we have verified in version 5.4 and 5.15. And also we verified only in the client cluster. So this is the reason we put the requirement here. So let's take a look about the overall design idea. So basically, the eBPF will be used within the kernel's traffic control layer in the data path. So especially the TC program will be hooked into the application pod and the tunnel virtual Ethernet pair. So the eSTL we want to repurpose it as a control plane for the eBPM program. So it will run as a daemon set. So this is similar to what Ambient has today. So, but all the original IP tables, IP rules, and the GNU tunnels ended by Ambient will be removed from the worker nodes. So the overall architecture you can get from this picture here. So basically, the eSTL it will watching the pod and the namespace event. So this logic already existed in the eSTL today. So we just we can just reutilize this. So after it got the pod event, for example, if the a new workload pod has been joined, Ambient mesh, we will execute related eBPF user space program. So this picture actually split it in two parts. The upper part is the user space part, and the lower part is the kernel part. So as I said, when a new workload pod has joined Ambient mesh, the eSTL it will call the user space program to attach the related eBPF program into the related pod VES pair, VES device on the host. So internally, we have two data structures to record the information for the tunnel and the workload info on this specific node. So for example, when the tunnel pod has been rescheduled or restarted, something like this, the eSTL will also call a user space program to do the CIUD functions, like to create, read or update or delete the Z-tunnel information we stored in the Z-tunnel array. Because there is only one record, so we select array as the data structure here. For the APP info, we select a map here because there are multiple pods in the same node which belongs to Ambient. So basically, we will record, for example, for the workload pod or the workload APP, we will record the MAC address for the VES device on the host for the pod, the F index, and their IP information, the pod IP for the application. For the tunnel, we also will record this information. So the eBPM program running in the kernel space will read the information in the map or array and attach or execute the related redirection logic according to the stored information in the map or array. So this is a control plane architecture you can think about. Then for the data path, I mean the eBPF program running in the kernel space, this is the architecture for it. So basically we hook the TC program into 4 hook points. So in this picture, you can see there is an app client, app pod. So it may acting as a client or acting as a server. So just the app pod, and the bottom part is the tunnel part. So they have the west pair. One end in the is running in the is residing in the pod itself. The other end is reside on the host. So this is the meaning for these 2 green nick here. So for the app pod, we hook the TC program into the ingress and the egress part, but both are on the west on the host part. So in the ingress part, actually we rely on a special outbound MAC address. So when the traffic coming out from the application, we will get this packet, and we will add a special, we will modify the source MAC or this packet to a special outbound MAC address and redirect to the data tunnel. Then on the lower left side, it comes into the data tunnel part. So in the data tunnel part, there are 2 hook points. One is hook inside the west within the data tunnel part. The other is hook on the host part. So when the traffic or the packet coming into the data tunnel pod, within the data tunnel pod, I mean, so we will look up the connection. If this is a new connection, then we will leverage the T-proxy IP table roles to the to the data tunnel outbound pod. So one thing to mention here is for the data tunnel pod, we currently still rely on the IP tables and we still rely on the IP tables and the T-proxy to redirect the traffic, but the GDU tunnel has been removed in the Z tunnel. So this is the thing. And this is a future enhancement point we want to do. Also in this hook point, when the tunnel, when there is a ingress packet, we will also look up the connection, and if we if this is the first, if the packet the first time come in, it means not found. We will T-proxy to the inbound port for the tunnel. So then in the right side, it's the TC ingress hook point. So this hook point is hooked to the west on the host side. So as we as we keep a map in the kernel path to record all the pod that is managed by or is running on this the tunnel node. So we will do a search to see whether the destination IP is within the range. If it's within the range, then we will redirect to the related pod. Otherwise, it will just go through the normal traffic flow. Then in the right upper side, so this is the egress hook point. So we also rely on the special inbound MAC address. So then we will redirect it to the tunnel. So this is some basic information for the data path flow. For the deployment model part, we plan to package all the EPPRAM program in the ECL pod, and we will for the user part, no code or deployment change is required for them. As we said, we have tested out using the kind cluster, and we have tested in both the NVO and the Rust tunnel version. The last part is some future improvement, and we hope to get the feedback from community. So the first one, as I mentioned, within the tunnel part, we still rely on the T-proxy. So we plan to leverage eBPF for this part as well, but this might require some newer kernel version. So this is one direction. The other part is, so currently the Ambient can only work on the kind cluster or some specific, very basic CNI config cluster. So we need to work with different CNIs to make sure the eBPF hook can work well. For example, in the Calico part, they also hook some eBPF program in their CNI, so there might some conflict. So we need to work with them to see how to make sure this approach can work well. So also for the other CNI, they might also work as well. They also require some additional work as well. Then the other part is, currently, as I said, we have two special inbound and outbound MAC address to distinguish the traffic flow direction. So so we have checked the kernel code in this part. So the kernel, when they generate the MAC address for the virtual Ethernet, it will using some random one as well. So in theory, the conflict risk might be very slow, might be very low, but we still want to see if there are any other, new or better method to achieve this. So this is one thing we want to consider. The last part is we have one TCP/IP bypass solution that works well in the against the original ESTL sidecar mode. So the performance again, if you utilize this solution, is around 10%. So maybe in sometimes more than 10%. So we want to leverage this solution as well on top of current this redirection logic. So we will try to merge them together and see what's the final performance benefit. Yeah, so that's all for this proposal. So I'm looking forward to your feedback, especially for this part.
Ethan, you want to go first?
Yeah, so I have a number of extremely detailed questions / thoughts. So I don't know how much time we want to spend on that. But maybe I can just dig in, and if it's getting too much, I can stop. So overall, I think this is a reasonably good approach. Actually, let me start with high level stuff, and then I'll let other people ask questions, and then I'll get into like very wonky technical questions. A couple of points just in terms of kind of broad direction. The way I would see something like this is as a kind of reasonable default reference implementation. You mentioned trying to get it to work with Calico and other CNI vendors. It's great if we can get it to work there, but ultimately I would think people using other CNIs are going to want those CNIs to support redirection to Z-tunnel natively, if for no other reason than there should be a way to kind of integrate Z-tunnel with the other features the CNIs are giving, and I would think something like this would bypass the CNI entirely. So I would recommend not making that really a goal of the project. It's worth testing, but I don't think we should put a huge amount of code ourselves into getting every single CNI vendor to do redirection, but instead we should kind of publish a spec for how redirection should work and work with them to implement it in their code. Performance, I think, is important. It's probably a little early to overly focus on some of the more aggressive optimizations. I think just doing this in eBPF in the kind of lighter weight, more direct way that you're doing here than what's existing will perform better. And I'm much more concerned about something that's stable and works consistently well. So that's just a general thought. And then I have a bunch of extremely detailed technical questions, but I'm gonna let other people ask questions, and then we can close out with my extremely detailed technical questions, or I can comment them on the doc. Yeah.
Okay, thank you, Ethan. So maybe I forgot to do, I can demo something here, maybe if it can help to, understand the proposal.
Or feel free to demo. I understand the proposal. I have questions about some like edge cases, but the basic proposal totally makes sense.
I think we would probably love to see a demo, or if you have a recording for general audience. Ethan is definitely more advanced on this topic for sure.
Okay, so let me try to see whether I can get it to work.
Yeah, okay. As you get it work, I think Carsten, you're up next. So I'd like to pass it to you.
Yeah, my interest is more on the control plane side of this, or not necessarily data plane, but communication between CNI and zTunnel. And as you know, I'm particularly interested in seeing Istio running on VMs and other environments, not necessarily only on Kubernetes. And for that, I think it's super important to not get tied into MAC addresses and a particular solution to communicate, the local pods. And maybe even for Kubernetes to have a more simpler solution, because pod creation, pod deletion are not very frequent events and not performance critical. And having gRPC or some other HTTP call between the CNI and zTunnel to communicate the information about the pods may be simpler than eBPF. I don't know, but either way, I would like to have one solution that is independent of eBPF and can be run.
Yeah,
run zTunnel.
Can I actually address that one? Because I've been thinking about it a lot. And I actually put on the agenda something to talk about. I think there is a redirection strategy that I'm actually having Brian, I don't know if he's on the call, work on. That is just simple IP tables that's possible that will work very, very cleanly for VMs and other cases. I'm also uncomfortable with the MAC address thing for different reasons, which you can get into later. But I do think that we're going to have a little bit of heterogeneity in how the redirection work depending on the context. But I agree that this would not be appropriate on a VM. It's very complicated in that case.
And on Android, for example, it must be done, because that's the only thing that Android supports to intercept packets. So again, there are some. I mean, we need to be flexible. I mean, the interception may have multiple solutions. There is no question about this. My concern is really only about having a metadata, the metadata exchange, where CNI telling zTunnel, information about the pod or whatever is necessary, have an alternative that is based on HTTP or gRPC. Yeah, that's it.
Yeah, I would say I think in general, there's going to be multiple redirection solutions for different environments, right? Now we need the basic one for if you just install Istio and you're unkind or whatever. Then a vendor like Calico or Cilium may implement a better one that's specific to their CNI. We may have one for VMs. Maybe we have one for Android. But on the metadata though, that part's not quite clear, because whether it's ingress or egress is not a property of whether the pod is local on the node. It's a property of the direction of the traffic, right?
Yeah.
It is very important to know if a pod is local, because there is different code paths, different. I mean,
I totally agree. It's important to know if the pod is local or not, but that's not the same. That's not enough. We also need to know if a given request is egressing or ingressing to that pod.
And also metadata about the pod. I mean, what is the pod ID, whatever, because we don't want zTunnel to connect to API.
So the pod information is over XDS. That part I think is established.
No, but it can come from CNI. I think that's part of this document. I don't know if I understood correctly, but the CNI, when it does its magic, the eBPF, MAC, and all the other stuff can communicate metadata to.
Right. The only metadata it's trying to communicate though is the one thing that we can't get from XDS, which is this connection inbound or outbound?
So yeah. I think actually, well, first of all, if you're running in the host network namespace, you don't need that, because we can just redirect to the ingress regress port. I would recommend we shelve this conversation till the ingress versus egress versus. I actually think we want like a local pod bit, but I recommend we shelve it until next week, because I'm literally writing a very detailed doc on it, and it might be a better basis for arguing about that. And I think it's kind of orthogonal to the proposal that's here.
So Costin and Joan, your suggestion is because currently we rely on the traffic flow information determined by ourselves not the metadata from XDS to define the traffic direction. So your suggestion is whether we can leverage XDS for this part? Is this the one?
No. For direction, I agree with it. I mean, it should come from interception and whatever, eBPF or interception.
Mm-hmm.
How you direct traffic to the 2 ports, that's all in the data.
Okay.
While we're on this, my only feedback would be I don't like using the MAC address for this, but I'm not. I've been wringing my hands on it, but I'm more or less convinced that some sort of tunnel header, like a Geneva header, is actually the right way to indicate this bit. But we can debate it. Maybe we should do the demo first.
Yeah, let's do the demo, and maybe next week, Ethan, I would like you to take the team through the requirements, because I think that's important for different players on this call too.
Okay, so let me go ahead with the demo. So you can see currently in my system, in my system, the CNI has been removed totally. So and we, as the prototype, we do the control plane part for the eBPF manually. So you can see there are no ESTL CNI. We attach the eBPF program and update the related map and read manually. But in the future, we will manage all the logic in ESTL CNI. So and then you can see if I go to the worker node. You can see there all the IP table rules added by Ambient has been removed. And if I send a request, you can see here. And if I, we can also see some eBPF trees here. See, it will know the tunnel redetect to APP, and for the debug purpose, we have output all the flow in the trees, so you can see on the line the eBPF is taking action here. So yeah, this is a quick demo for our current environment. Yeah, so we can go ahead with the discussion now.
So can you talk about the CNI? Is there any additional privilege or permission you have to give to Istio CNI to run the eBPF code?
Currently the Istio CNI has already run on the host network mode. So in theory, I don't expect any more privilege required for Istio CNI based on current version. But as I said, all the control plane part work for the eBPF has been done manually currently. So we will see if we integrate all the logic into Istio CNI, what's the change required. But in theory, should no more privilege required.
Okay. The other question I've been having is, can you maybe highlight for audience who are not familiar with your proposal and the Murbridge proposal, which they also indicate they are adding ambient support? Can you highlight the differences of the two?
Actually, I may not. I haven't touched more detail about the Murbridge implementation. So we just go ahead with the TC hook in our side. So no comparison has been done between the two approach. But one thing I got from the Murbridge part is they currently cannot work on the kind cluster. So
I know enough about the Murbridge proposal that I can. They're capturing traffic at the socket from the application. And my understanding of this proposal is it's capturing packets as it egresses the pod in essentially the TC hook, which is kind of vaguely related to where IP tables runs in the core kernel anyway. I think the difference is going to be this proposal has the potential to be much more stable and robust in the long term. The Murbridge proposal, there will exist benchmarks for which it's faster, right? But it's a little bit more fragile and finicky, probably. I'd say I'm 50% confident on that. But that's the main difference. Murbridge is capturing at the socket in the application and shoving directly to ztunnel, so you skip the entire Linux networking stack. And this is still going through the Linux networking, so it's a much maybe smaller change.
And I noticed one of the key differences is the kernel requirement, because Murbridge has much higher kernel requirements. To your point about thanks to Ethan. Any other questions from anyone?
I have some quick wonky technical points. Or maybe it's a question. So you're capturing traffic as it egresses the pod VETH, right?
Yeah, we catch in both directions from pod part, the ingress and the egress. Yeah.
So does the proposal work? Suppose I have a non-ztunneled pod and a ztunneled pod on the same node.
Mm-hmm.
Or actually, it's a simpler case. Suppose I have like an endpoint in the internet sending traffic to a ztunneled pod, and that endpoint in the internet doesn't speak HPone. So one of the requirements is the traffic that goes to the pod, since it should be captured by Ambient, gets redirected to ztunnel instead of being sent directly to the pod. Does the proposal handle that case? Am I making that clear?
Yeah, you mean if one pod is outside ambient scope, and for example, the client side is outside ambient scope, but the server side is in ambient scope, will the connection break or not, right?
Will traffic get redirected to ztunnel?
So in our proposal, we have a map, and this map record only the pod information and managed by Ambient. So if it outside of Ambient scope, it will not be redirected.
Okay, so that's
the destination we still want to be captured by the ztunnel, right?
Yeah, so that'd be a piece of feedback I think it's possible with the approach you're taking. So it'd be like the next thing to work on. If I have a destination pod, a server pod that's in Ambient, all traffic to that server pod, whether it's coming from even random points on the internet, needs to be redirected to the ztunnel. Does that make sense? And again, up next on the agenda, I'm writing a very detailed requirements doc that I've committed to finishing by Friday. So I'll send that out, which covers some of these more like less obvious edge cases. So it might be a good idea to kind of cross-reference what you've currently got implemented with that. But that's the biggest gap that I thought I noticed. And then the second one, I'm pretty uncomfortable with using the MAC address.
The reason for this, originally we want to leverage the MAC part for the SKB, but this doesn't work because the packet has cross network namespace, so the MAC has been lost.
Right. Yeah. So the only two viable options I've heard are using the MAC address as you suggested, which I had not thought of before reading your doc, and it's clever. So I'll have to think more about it. The concern I have is, what if a pod on the node that's not part of the mesh learns that MAC address and sends traffic to it? Can it trick ztunnel into thinking?
We just modified the source MAC address. So that destination MAC address, we doesn't touch it. So it should be okay. So the only thing we worried is the special source MAC we selected is conflict with others. But after checking from a lot of, information, we find the conflict risk is rare. But
you could allocate a MAC. That's not a like if it you could. There's parts of the MAC address range that aren't used that you could. So that I'm not so worried about. Could you add to the doc more description of the MAC address stuff, and I'll look at it out of band. I'm not convinced either way, but more detail would help. And that's my only other kind of like broad bit of feedback.
Yeah, sure. We can add the special MAC address we currently use in the doc.
I'm curious about like how you send it, or I'm curious about how and when you change the MAC address in the pot. I'm just curious about all of your thinking about the MAC address stuff.
Not just change the packet source MAC address and using that as a flag to mark the traffic direction.
Okay, I'll think about it a little bit further. That was my stuff.
Okay, cool. John, you're up next.
Yeah, I was going to say, instead of updating the doc, is it possible to just open source the code? Then code's much better than docs.
Yeah, so this is the question I want to bring up here as well. So do you think we can upstream it in the Istio main repo, or what's the better approach to upstream this part of work?
In my opinion, we want at least one general redirection mechanism in Istio core. I mean, we have to have one, right? You have to be able to install Istio and it works. That could be this solution. I would be open to that potentially. I mean, I can't say that it will be the solution until we see the code, obviously, and try it out and whatnot. But I have no reason against that. So yeah.
So I guess my concern would be, we want some solution to replace what we have, but in the condition, it's better than what we have, right? So far, what you have, it looks promising. I think maybe make more sense to open source somewhere some people can play with. Maybe it could be a branch, right? Even though we're already a branch, and then we can evaluate on that. Because right now you have a lot of manual steps. I don't think it's actually functional equivalent as the CNI we have at the moment.
Yeah, especially for the control part. So we need to add all that manual step in the CNI. So maybe we can have an experimental branch. Then we can contribute the code there. And if all the part has done, we can see the possibility to merge it back into the mainstream.
I wouldn't say necessarily it has to be a branch. I mean, we can have some directories in CNIs and some options. I'm pretty sure we'll have some BPF loading, and definitely CNI will be involved in the picture. So, we had all kind of experimental features. As long as we get rid of them, if we find out we don't use them, I think it's fine to not bother the branch.
Okay.
And then I'll just give like a quick vote of confidence. I mean, there are details that need to get kind of more fleshed out before I think we should merge it. But I do think in general, we're going to end up with a BPF and an IP table solution merged upstream. And I like this approach a lot better than the Murbridge approach. Just because I have a pretty strong intuition that this is likelier to be more stable. And that's what I care about for the default one, at least. So.
Yeah, I agree. I prefer this approach over Murbridge. The other thing, though, it seems like most of the redirection issue is all about inbound versus outbound detection. Maybe we should just bite the bullet and do it in ztunnel instead of at CNI.
John, can you and I talk about this one out of band? I don't think it's as hard as you think. We've been talking about it the past couple of days. I don't think it's as hard.
No, I know. That's what I'm saying is maybe we should just do it. Like,
I think it's important to keep Z-tunnel as small as possible. I mean, it's Rust data plane, wonderful, but let's keep any metadata or anything that is, there is a space for Go as well, for some.
Let me explain why I wanted to have two separate ports and have the redirection tell us whether it's ingress or egress. Because I think you can look at the source and destination IP and try and derive which direction the traffic is. The issue is that if you ever get that decision wrong, it is one of the worst vulnerabilities that you can have in Istio, right? That is absolutely horrendous. So doing it based on what we know about pods from XDS, it just feels a little bit potentially risky. Whereas the CNI, it knows for sure whether it's ingress or egress, right? That's something very clear at the V level where the traffic is going. So it felt more reliable that way. If it ends up that it's causing all sorts of headaches and blowing up everything, then maybe we just drop that. We determine it in Z-tunnel and we try and make ways to make sure that we don't mess up.
I think any solution where we're trusting the IP address, like I don't think that's going to get past security review. That's why I think this is important.
We already have to trust the IP address to determine which outbound certificate to use, right?
That's exactly what I was going to say. I mean, the IP address is a source of truth in this model because
it is and it isn't. So if the CNI tells you this packet came from a pod on the node, and the CNI is verifying the source IP of that packet, then I think it's okay to trust that source IP to pick a certificate for that packet. The concern is, and it becomes an even bigger concern once we allow kind of raw packet forwarding, is some random endpoint on the internet sends a packet to the Z-tunnel with a source IP of a pod that's on the node, and Z-tunnel forwards it as if it's that pod. I don't see how to get around that.
We are only talking about local IP addresses, which are also in a CIDR range, because each node gets assigned, a specific CIDR range. So it's not even doesn't need local lookups, and they cannot be forged because you cannot, they are private IPs and they are, local to your host. It will not accept from the internet request to your local host.
I mean, yeah, I've got a pod. I've got a non-enmeshed pod on the node that's in a different security group, and it sends traffic with a. We don't have it's a security. It's frightening. It's very scary.
I agree with you. I do agree with you that keeping two separate ports and having multiple layers of security is good. But let's not say that IP address is not trusted, at least for the local addresses. And
anyway, John, let's you and I talk about this out of band. I don't think setting the bit is that hard. I don't think we have to give up on this. I think it's pretty easy, actually.
Okay, anything else we want to discuss? Is there anything worth bringing up from the chat?
About the MAC address, did you looking at the SKB CB field? I don't think it's scrubbed across namespaces.
We just tried the SKB MAC field. You mean the CB field?
Yeah.
Okay, we can check if you mean the CB field will remain maintain even if cross network namespace.
Yeah, I remember looking at SKB scrub, and they scrubbed the MAC, but I don't think they scrubbed this callback, the CB.
Okay, thank you.
Can you let me know if that works? I'm extremely interested.
Sure,
Yeah.
Ethan.
Okay, so Iris, I think we got sidetracked. Are you going to push the code somewhere so we can take a look at it?
Yeah, sure.
Awesome. Thanks.
Yeah, that's thank you, Iris. All right, I think we are done with this topic. So thank you again, Iris, for presenting the idea, and also thank you for the great demo. It went very well. Next up, we have a quick topic on Ambient board. So John and I have been putting together, you guys all know we have a Z-tunnel board, and thanks to many of you already jumping to help out with the Z-tunnel work item on the board. So if you click on the link, you should be able to see the Ambient tracking board at the moment. So we're probably still continue going to populate more items, but you can see a lot of tasks in the backlog and also up next. So once to get it out in your eye, if you're interested in helping out something that's not relevant to zTunnel, because I know at one point John mentioned zTunnel was a small project, and also some of you share, you're new to Rust, so maybe the rest of Ambient could be interesting. So definitely worth checking out the board and signing up for things that's interesting. The other thing I want to share is Francis from Google and us are running a twice by week stand up. So if you own an ambient work item, please assign to you, and then we'll invite you to the stand up once you own a work item. John, you want to add anything?
Yeah, the other thing I will say is that on the ambient, especially zTunnel, we're kind of in a unique situation in the project that we have a bunch of people trying to work on a relatively small number of tasks. If you are owning an issue and you get reprioritized to work on something else, you realize that maybe you should have started with a smaller issue to get started and ramped up in Rust or whatever the case is, please fail fast and let us know. There's definitely people that are willing to pick up any tasks that are dropped. So just make sure that we're not waiting on someone to work on something that's never going to happen. And if it is the case of you feel like you're in over your head, let me know. There's plenty of beginner ramp up issues that we can give if you're interested in contributing, but took on something that was harder than you expected.
Yeah, great point. In fact, we had one of our guys signed up something and realized he's not the right person to do it. So there's no need to apologize. Just inform. Eris, go ahead.
Yeah, so Lynn just mentioned we will have a bi-weekly stand-up meeting for the guys who involved in the ambient task.
Yeah, that's why we want to make sure you guys sign up for the redirection task. I think there are a task for that, and then we should be able to invite you guys to the meeting, to whoever work on the task.
Okay, thank you. So one thing is, some of my members are in different time zone, so it will hard for them to attend the stand up. So
yeah, maybe you can join on behalf of them if that's the case. Yeah, it's in the afternoon, so will be too late for them.
Yeah, I'm just wondering whether it's possible to publish at least the meeting notes.
That's a great point. I don't think. Okay, so we don't take notes. The reason is every notes is in the GitHub. So basically, the way we work in that meeting is we have each owner provides an update, and then we update the GitHub. So you get the notes in the GitHub already. Does that make sense? Yeah, there's no private notes.
Okay, thank you.
Yeah, sure thing. All right. Anything else anyone wants to bring up?
I have just a quick FYI and request for feedback. Code spaces have been enabled for the zTunnel project. So I'll give just a quick demo of how to get started. We won't follow through the whole thing. But,
yeah, we would love that. Yeah.
So you should be able to see my screen at the zTunnel landing page.
Yes.
Yeah, we can see it.
So you just click on code and create a code space. Billing for the code spaces is totally up to you. GitHub gives free users 120 compute hours a month. If you want more than that, you can purchase more than that. I'm working, this is actually remarkably slow. I'm working with GitHub to get pre-builds set up so that your experience of getting up and running with zTunnel and getting the zTunnel built for the first time should be like a 30-second operation, as opposed to, I think right now it's about 15 minutes. But, oh, you guys can't see the other part of my screen. So what's happening since I clicked that button, Visual Studio Code has automatically opened and is working on connecting to a container on GitHub. And that's it. From there, you can do your development, you can push commits, review PRs, etc. So really would appreciate any feedback people have, any snags they hit along the way using this. You can also open it not in VS Code if you want to use it like in IntelliJ or in the browser. That's also possible.
Very cool. Is there a guide for people willing to try this? Like a README or something? Oh.
There will be one for Istio particularly, but for now, there's just the GitHub Codespaces documentation. But it is pretty simple, just 2 clicks. I can here, actually, I'll demonstrate opening it in the browser here, because that is something you all can see. The reason that I'm interested in feedback, particularly over the next few weeks, is we would like to make this pattern apply to all repositories in the Istio organization. We're also working with the CNCF to get compute hours donated to the project from GitHub. So any feedback you have now will help us at a time where we can fix the problem in 1 repo instead of having to fix it in 12. So.
That's great. Thank you so much for sharing this, Mitch.
Yeah.
All right. Anyone have anything else to bring up?
I'd like to have a really wonky conversation about redirection with John, which I would invite everyone else to leave because it's going to be boring. But I figure we can have it in here in case there's interest. So is that okay?
Now, do you maybe stop the recording then? Yeah.